Hello everyone, welcome to our next presentation, which is all about straight lines. We're gonna recap what you've learned at GCSE, which is a lot, and we're going to take it further and look at some A-level aspects as well. Now a little starter for you, I'd like you to have a go at plotting these curves, please. If you are at home and you haven't got graph paper, then you could perhaps use some squared paper, but I'd like you to plot them, and then we'll have a look at the characteristics after you have done that. So pause the presentation, have a go, and when you're ready, come back to me and I will go through some answers. Good, so number one, y equals 3x minus 1 looks like this. It passes through minus 1 on the y-axis. We call that the y-intercept. It has a gradient of 3, but we will mention that in a little bit more detail later on, and it has an x-intercept of 1/3, and we could find that value by making y equal to 0. Number 2, this is our graph of y equals minus x. You'll all have seen this at some point before. It goes through the origin, has a gradient of minus 1. Number 3 is y equals 1 plus 3x. It has a y-intercept of 1. It has an x-intercept of minus 1/3, and it has a gradient of 3. Number 4, y equals minus 2x plus 3, has a gradient of minus 2. It has a y-intercept of 3, and it has an x-intercept of 1.5, or 3/2. And finally, number 5, this is our graph of y equals 1/2 x minus 2. It has a y-intercept of minus 2, an x-intercept of 4, and it has a gradient of 1/2. I forgot to mention earlier on that to find the points upon which you can then draw a line, you can draw a table of x and y values, or you can just find 2 or 3 points from the equation that work, and you can then plot your straight lines from that information. Okay, so I've talked already a lot about the features of straight line graphs. Let's look at them in a little bit more detail. So first of all, let's look at the gradient of a straight line, and this can all be written down in your notebooks, please. So the gradient is a measure of how steep the line is. So in order to find that gradient, we can draw a gradient triangle. So we would choose any 2 points on the line, doesn't matter where you choose your points from. And we would measure how far up and how far along, sometimes called rise and run, sometimes called difference in y and difference in x. However you've been taught at school, I'm fine for you to go along with that. And then to work out the gradient, we divide the change in the vertical axis by the change in the horizontal axis. Rise divided by run, up divided by along. And here is a more mathematical statement to describe how to calculate the gradient. y2 minus y1 divided by x2 minus x1. And you can see where those y values and x values are on the illustration on the right. Good, so let's go straight into a question. There's lots of different types of question that they can ask you in this respect, but in this particular question, we are looking to find the gradient of the line that goes through these 2 particular points. So in the first instance, I mean, there's quicker ways of doing this, but let's look at how to do this fully. So we can draw ourselves a little diagram to illustrate where those 2 coordinates are in relation to each other. And you can see how this line has a positive gradient because it's sloping upwards from left to right, and that's something that we'd have to take into account if we're using this method. I can see that my x values are -5 for my first coordinate and 3 for my second coordinate. And I can see that in terms of the y values, I've got 4 on my first coordinate and 6 on my second coordinate. And so I can now use those values to work out the gradient. So difference in y over difference in x. So I've chosen to do 6 take away 4 for my two y values. And if I choose to do it that way around, then I must make sure I take the x values in the same way. So 6 take away 4, second coordinate take away first coordinate, I must keep the same order for which I'm doing my subtraction with the x values as well. So 6 minus 4 for the y values, 3 take away minus 5 for the x values. So be careful, there is that double negative there. And if I do the subtraction correctly, I end up with 2/8, which does simplify to 1/4. So by doing this way, where I'm keeping the same order for my subtraction, I don't have to worry about whether the gradient is positive or negative, because that is determined in my final answer. So you can see here I've ended up with a positive answer, which means that my line is going to have a positive gradient. Before I move on, I could have done it the opposite way around. So I could have done 4 take away 6 for the difference in my y values, but then I would have had to have done minus 5 take away 3 for my x values. I must keep the order the same for when I'm doing my subtractions. And I would have got the same answer, of course. Okay, so carrying on in our notebooks, please. There's lots of notes to write in this presentation. The equation of any straight line can be written in 3 different forms, and it just depends on the question. It depends on how confident you are with each of the 3 types. That will often make your decision as to how you're going to approach the question. But there are 3 main ways of writing the equation of a straight line. The first, and probably the most well known, is y equals mx plus c. So sometimes it's appropriate to use this version, sometimes it's more appropriate to use the other 2 versions, so we need to be aware of all 3. So in this version, the m represents the gradient of the line, and the c value represents where the line crosses the y-axis. We sometimes call that the y-intercept. So this question is a similar question to before, except that rather than just finding the gradient between the 2 points, I'm then moving on to also find the equation of the line. So the first thing I'm going to do is find the gradient. That's going to give me my m value, and I'm going to do it using the method that we saw on the previous slide, but this time, because we're a little bit more advanced in this method than perhaps we were before, I'm not going to draw a diagram. So I'm just going to use my coordinates, look at the values and use those. Remember, the negative positive gradient will come out from the maths. You don't have to draw a diagram to determine whether it's negative or positive. So minus 1 take away 5, you can see the 2 y values there, and you can see the order in which I've done them. So I'm going to do the same order for the x values, 7 minus 4, quick bit of maths, minus 6 over 3, and very nicely for us, that gives us a whole number of minus 2. So a negative gradient, minus 2. We are not going to find c directly, we're going to find it from the information that we have now in the question. So I'm going to use the gradient, which I've just worked out, and I'm going to use one of the 2 coordinates. It doesn't matter which one you choose, you're spoiled for choice. I am going to use the 4, 5. I'm guessing that's because they're both positive values. It seems like a nicer coordinate, but 7 minus 1 would work as well. So I'm taking my y equals mx plus c, my equation. I'm replacing the y value with 5. I'm replacing m, the gradient, with minus 2. I'm replacing x with 4. And that then enables me to find the value of c, which is 13. So that's it, job done. I found what m is, I've now found what c is, and therefore the equation of my line is y equals minus 2x plus 13. And if you have got a bit of time, try the same question but use the 7 minus 1 instead of the 4, 5, and you will see that you get the same answer. Okay, so here is my second form for which I can write a straight line. It's not used as much at GCSE, but some of you will have seen this before. So here is the alternative: y minus y1 equals m lots of x minus x1. So m represents the gradient again. Y and x are our two variables, the same as they were in y equals mx plus c. And then x1, y1 represents our coordinate. So same question, same coordinates. Let's just make sure we get the same answer using this form for our straight line. So I'm going to again work out the gradient first. Well, I don't really need to do that because I've already seen that it's minus 2 from the previous slide. And then I'm going to choose either of the two coordinates again. So again, I'm going to use the 4, 5 because it looks to be the easier of the two coordinates. And so I'm going to replace x1 with 4. I'm going to replace y1 with 5. And I'm going to replace m with minus 2. And the answer that you now see in the bottom right hand corner is a valid answer. That is the equation of a straight line. We've got the y, we've got the x, all the other unknowns have been filled in. However, just a bit of a word of warning. If you are going to use this method on the mark schemes for the A-level exams, you must collect together the like terms. So we do have to multiply this out, and we do have to combine any terms that you can. So please bear that in mind. We'll have an example of it later on, and you can see that in action. But multiply out the brackets and make sure that you combine those two numbers together. Otherwise, you will lose marks on the mark scheme. Here is our final version, which is just really a rearrangement of y equals mx plus c, but quite often the exam paper will ask for it in the form ax plus by plus c equals 0. And they'll also sometimes ask that a, b and c are integer values, whole number answers. Sometimes they don't bother, but just read the question carefully and make sure you know exactly what form you need to give your final answer in. So as it says here, a, b, c are integers 95% of the time. That's what is required. Sometimes if it doesn't mention it though, you don't necessarily have to have a, b and c as integers. Just read the question carefully and see what it asks. So let's demonstrate that with a question. So this time you get given the gradient. We don't have to calculate it. We don't have a choice this time of coordinates. We've got 2 minus 6 and we have to use it. And our job is to write it in the form ax plus by plus c equals 0. So we're going to go back to method 1. We're going to write it in the form y equals mx plus c first, and then we'll rearrange it to the form that we need. So I'm going to replace y with minus 6. I'm going to replace m with minus 2/3. I'm going to replace x with 2, and that will allow me to find c. So I've done exactly that in this line, and then rearranging, you get c being minus 14/3. Not a whole number, but like I've said before, at A level, don't expect integers for all of our answers. So here is my straight line in the form y equals mx plus c. It's now my job to rearrange, to manipulate the algebra so that it's in the form that I need. So the first thing I'm going to do is multiply everything by 3. And don't forget, if I am going to multiply by 3, every single term has to get multiplied by 3. So by doing this, I'm getting rid of the fractional element, leaving me with integer coefficients. And then last of all, I need to bring everything over to the left-hand side to give me my final answer of 2x plus 3y plus 14 equals 0. And I've written those terms in the same order as they wanted me to write it in the question. Good, so over to you, bit of practice. There's a lot going on there, so there'll be lots of opportunity to practice those skills within this exercise. Any problems, speak to your teacher to clarify any misunderstandings, or if you're not sure about anything, please ask. And then after you've had a go at this exercise, you can move on, and I will see you on the next slide. Good, so the next item that we need to look at is finding the midpoint between 2 points on a line. Common question. It's often linked with other types of question as well, so it's a skill we need to be confident with. So here's my straight line. Here are my 2 coordinates. I'm being very general here. This can all go down in your notebooks, and there is a formula that we can use to find the midpoint of this straight line very quickly. And the idea is that we add the 2 x values together and half, and then we add the 2 y values together and half, and that becomes our new coordinate. Just be a little bit careful. It is not x1 plus y1 divided by 2. It's x1 plus x2 divided by 2. So just be careful when you are doing your calculating. So here's an example, 212 and 815. I've replaced those 2 coordinates on my line, and my job is to find where the middle of those 2 coordinates would be. So I've replaced at the bottom of this screen, I've replaced x1, x2, y1, y2 with the relevant numbers, and then it's just a case of performing the calculation and coming up with a midpoint of 5, 13.5. Okay, good, and now it's time to find the distance between 2 points on a line. So in the previous slide we were finding the midpoint, this time we're finding the distance. So here's my straight line, here are my 2 coordinates. How can I work out the distance between those 2 coordinates? Well, I can use Pythagoras theorem. So here is my right angle triangle linking the 2 coordinates together. So I'm going to take away the 2 x values to find the length of the base. I'm going to take my 2 y values away to find my perpendicular height, and then I'm going to use Pythagoras theorem to find that length between the 2 coordinates. So to give that some context, to give it some actual numbers, here are my 2 points, 4, 6, 7, 8. I've replaced those values, and I can see that the difference in x is going to be 3, the difference in y is going to be 2. Of course, we don't have to worry too much about negatives and positives because these values are going to be squared anyway. So 3 squared plus 2 squared, all square rooted, gives me an answer of root 13. And unless it asks me, I'm going to leave my answer as a third. Okay, good. So now it's time to practice those skills with this slide. It's a nice little task, this one. It practices finding lengths of each side of the triangle. From that, you can then determine what type of triangle it is. Then you're finding midpoints and finding the distance between 2 midpoints. And then finally, find the equation of the line through A and the midpoint of BC. So we're looking for the equation of the line that's going through A and the midpoint of BC. So have a go at that question, and then when you're ready, you can start the PowerPoint again and I will give you some answers. So first of all, lengths of sides. So you should find that the length between A and C is root 61, as it is with AB as well. And the length of BC is the square root of 122. From that, what can you tell me about the triangle? Well, 2 sides are the same length, 1 side is different, so you can say that the triangle is isosceles. We've now got to find some midpoints. So here are our two midpoints, 0, 3 over 2 for AB and 11 over 2, 1 for AC. And a quick calculation will tell you that the length of that line between the two is a half of root 122, or a half of the length from B to C. Finally, find the equation of the line that goes through A and the midpoint of BC. So here is my midpoint between B and C, 5 over 2 minus 3 over 2, and then you can use either of the three methods that I've shown you earlier on to find the equation of a line, but this is the line that you're trying to find the equation of, and it turns out that the equation is 11x, or y equals 11x minus 29. So nice integer values for M and C, but I haven't gone through a method there because you can choose a method that suits you, but as long as you end up with the correct answer, then all is good. Okay, another little task that you can do either on graph paper, or if you haven't got graph paper you can use square paper, is to plot these three graphs. So choose a suitable set of axes, you choose the x values, you choose the y values, plot these graphs, and then we'll have a look at them once you've had a go. Okay, good. So here are the three lines. Each of the original equations I have rearranged into y equals mx plus c. So the first line is y equals 2x minus 1, which is actually the middle of these three lines. The next one is y equals 2x plus 3 over 2, which is actually the line on the left. And then finally, y equals 2x minus 5 is the graph on the right. And of course, what we notice about those three lines is that they are all parallel. So what makes those three lines parallel? Well, the three equations that I gave you to look at all have the same gradient. They all have a gradient of 2. And that's the next thing that we need to investigate. Okay, so in your notebooks, two lines are parallel if they have the same gradient. So a definition that is often needed in a question. So if you're looking at a question that involves parallel lines, it's often important that we give that definition. What do you know about those lines that makes them parallel? So this would be your opening line, and then you would work with it. So two lines are parallel if they have the same gradient. So a question, find the equation of the line that is parallel to y equals 3x plus 4 and goes through minus 2, 6. So very similar style question to what we've already seen, but new information as it arises we can introduce into the questions that I'm giving you. So where's our starting point? Well, I want the equation of the line. So what do I need if I want the equation of the line? I want a point that it passes through. Well, great stuff, minus 2, 6. I've already got that information. And the second thing I need is a gradient. Now, my line that I'm comparing it to is y equals 3x plus 4. I know that that line has a gradient of 3. And therefore, if my line is parallel to this one, then my line is also going to have a gradient of 3. So I've now got all I need to be able to complete this question. So m is 3, gradient is 3, because it's parallel to the one that was given in the question. I've got my minus 2, 6. So I'm going to go down the y equals mx plus c method. I'm going to replace y with 6. I'm going to replace m with 3, I'm going to replace x with minus 2, and that will allow me to find the value of c, which is 12. So my equation is y equals 3x plus 12. Good. So the final aspect of this presentation is looking at what happens when two lines are perpendicular rather than parallel. So we've already studied parallel. Let's now have a look at perpendicular. So on your square paper again, or whiteboards, it is good practice to be plotting these graphs. So y equals 2x. We know what y equals 2x looks like. We know that it is going through the origin. We know that it has a gradient of 2. We know that it is a straight line, of course, so you can plot that line on your graph paper or square paper. And then what I'd like to do is to draw for me on the same piece of graph paper or square paper. Can you draw me a line that is perpendicular to it? So meets at a right angle. That's what perpendicular means. They meet at a right angle. Now, if you are able to do that, you can then find the gradient of the new line and you can write it down in this table. And then I'd like you to repeat the same again with the other 3 lines. And from that, we'll be able to see some patterns and decide on the rules for gradients of lines that are perpendicular rather than parallel. So have a go, and when you are ready, move on and I will give you some answers and we can discuss what we've found. So y equals 2x, the gradient of 2, you can either see that from the equation itself, or if you've plotted the graph you will be able to find it from there. And if you have done your perpendicular line correctly, you will find that there is a gradient of -1/2. Similarly, with the second line, we can either draw the line and find it to be 4, or we can see that it's 4 from the equation itself. And if I draw a line that's perpendicular to that one, we would find that the gradient is -1/4. So there's definitely a pattern developing there. If I have a gradient of 1/2, which I have for my third line, we would find that a perpendicular line has a gradient of -2. And finally, if my original line has a gradient of -4/3, it turns out that a perpendicular line has a gradient of 3/4. So what have we learnt from this table? Well, I think that it's fairly obvious to see that a gradient and a gradient of a perpendicular have opposite signs. So if the gradient of the original line was positive, the gradient of the perpendicular line is negative, and vice versa. But also, I'm hoping you notice that the gradient has been reciprocated. In other words, the fraction has been flipped. So this gradient of 2 that we had at the very start, well, 2 can be written as 2/1. Any integer, any whole number can be written as a fraction by making it over 1. So 2/1 has become 1/2, 4/1 has become 1/4, 1/2 has become 2/1, and 4/3 has become 3/4. So the gradient of the original line and the gradient of the perpendicular line are known as negative reciprocals. So time to write that down in our notebooks. So 2 lines are perpendicular if the gradient of one of the lines is the negative reciprocal of the other. Another way of thinking about that is if a line has a gradient of m, then a perpendicular line will have a gradient of -1/m. Or another way of thinking about it is that the 2 gradients, the original and the perpendicular, if you multiply them together, it always equals -1. And here is a little equation that will help to understand that. So all of these statements are valid, and they're all true for perpendicular lines. Okay, good, nearly there. We'll have a look at one question, which again can be written down in your notebooks. We have a straight line. You'll notice what form it's been written in. is perfectly acceptable. This is the ax plus by plus c equals 0 form, and we're told that it goes through the point 12, 4, and we need to find the equation of a line that is perpendicular to it. So first of all, we're going to find the gradient of the original line. So they've been a bit sneaky here. We have to do a little bit of rearranging before we can start. So here is the original. This is me rearranging it into the form y equals mx plus c, which means that I can then write down the gradient of -4. So I've now got my gradient, but I'm not going to use that gradient because the line that I want is perpendicular to it. So instead of using -4, I'm going to be using 1/4. So that's my perpendicular gradient, quarter. I've got the point that it passes through, which is 12, 4. I can then substitute all of that into y equals mx plus c. So I'm going to replace y with 4, I'm going to replace x with 12, I'm going to replace the gradient with a quarter. And that allows me to find c, which is 1. And then that leaves me with an equation y equals a quarter x plus 1. I don't need to change that back into ax plus by plus c equals 0 form. It doesn't ask me to, but if it did ask me to, then I would obviously do that. And if you did, this would be the answer. Okay, so a little exercise for you to finish this presentation off. I have got 3 coordinates that form a triangle, and my job is to find the perpendicular bisectors of each side. So before I let you loose on this, I think it's important that we talk about what a perpendicular bisector is. So if I take the line from A to B, just concentrate on the line from A to B for a minute, the perpendicular bisector will be a line that runs perpendicular to AB. So we know about that. We know that if we get the gradient between A and B, we can find the perpendicular gradient. And a bisector means that the line that we need is going to split the line AB in two. In other words, we need to find the midpoint. That's going to be the point that it passes through. So there's 2 jobs to do here. There's number 1, to find the midpoint between AB. Secondly, find the gradient between AB. Then find the perpendicular gradient, and then sub all of that information into y equals mx plus c. And you can do that for all 3 lines. So these 3 lines that you're creating are called the perpendicular bisectors, a very common exam question. And then finally, the perpendicular bisectors will all meet at the same point. And your job is to find where that point is. So you can solve your 3 perpendicular bisector equations simultaneously, and that will tell you where the 3 perpendicular bisectors meet. And that's your check to make sure you've done the question right. So have a go at that, and I will give you some answers when you have finished. So AB, here is the midpoint, -1, 1. Here is my perpendicular bisector. It works out, if you've done it correctly, and I've written it in this particular form, x plus 2y minus 1 equals 0. Here is the midpoint between B and C, 4, 0. Here is my perpendicular bisector, and it works out that the equation of that line is 4x minus 3y minus 16 equals 0. And finally, midpoint between A and C, 3 minus 2. And if I find the perpendicular bisector, it turns out that that equation is 5x minus y minus 17 equals 0. And if I solve those 3 lines simultaneously, Of course, I only need to solve it for 2, and then I could check it works for the third as well. It turns out that the coordinate where they all meet is 35 over 11 for the x value and minus 12 over 11 for the y value. Fantastic if you've managed to find that point of intersection. Good, and finally there are 2 exercises that cover those items that we've just seen: midpoints, distances, perpendicular bisectors, etc. So please have a go at lots of these questions. Get in contact with your teacher if there are any problems, and that concludes our work on straight lines. Rather a large presentation there, so well done. That completes that, and I will see you for the next presentation. Thanks very much. Bye bye.